Today, we are going to learn about energy generation during starvation. It is very important for us as a biology student to know what actually happened to our body during starvation. Let's begin! Do you know what is starvation? Starvation is a severe deficiency in caloric energy intake below the level needed to maintain an organism's life. In human, prolonged starvation can cause permanent organ damage and eventually death. Let's begin to the process of food digestion.
Oh my, I feel totally hungry. Are you guys hungry too? Can you guess what I will eat for my lunch? Let's say I will eat taco. The good thing is that taco contains carbohydrates, protein, and also fat. But I wonder, how can I get energy from taco? Let's take a look at this summary together. Carbohydrates. Carbohydrates yield glucose, which is degraded by glycolysis to yield pyruvate. Pyruvates undergo oxidation to produce NADH, carbon dioxide, and acetyl-CoA. Glycolysis also can produce NADH and ADP. Glucose also can undergo glycogenesis to store as glycogen. Next, let's take a look at protein. Protein will be stored as nitrogen pools and then converted into pyruvic acid. Pyruvic acid will be converted into acetyl-CoA. Same goes with fat and lipid. Fat and lipid will be converted into fatty acid spiral and next into acetyl-CoA. After that, acetyl-CoA will enter citric acid cycle and proceed into EDC to produce energy. Now, you got it. But what will happen in case of starvation?
During starvation, blood glucose level fall. So, how our body maintain blood glucose level? Glucagon travels to liver and stimulate glycogenolysis. There is an increase in glucagon secretion from pancreas and decrease in insulin secretion. Have you ever thought what will happen when the liver glycogen was depleted and no carbohydrates are ingested? In order to maintain appropriate blood glucose level, our body will undergo a metabolic process which is called gluconeogenesis, which leads to the synthesis of glucose from the pyruvate. Now, let's proceed to lipid metabolic pathway when glucose was depleted. Triglycerol will be broken down into glycerol and fatty acid. Glycerol will further to glycolysis while fatty acid undergo beta oxidation and both of them converted to acetyl-CoA and insert Krebs cycle, lastly etc. Other than that, some fatty acid is converted to ketone bodies, which is the major energy source for brain during starvation.
What reaction in beta oxidation?
Don't worry, partner. Let me explain to you.
There are 4 steps involved in beta oxidation, which is oxidation, hydration, oxidation, and cleavage of acetyl-CoA. In this process, an ATH and FATH2 are formed. For your information, different length of fatty acid shows different energy yielding.
Protein is a building block of amino acid, and hello guys! Now we move on to protein. What starvation does to protein and how can protein contribute to help you during intense starvation? During starvation, protein is broken down into amino acid. Amino acid can be converted to glucose in order to fuel our brain during starvation. The amino acid that can be converted to glucose is called as glucogenic amino acid, and the process is called gluconeogenesis, which is generating neo or new glucose from non-carbohydrate molecule. As a result, new glucose is used and can be used to produce ATP. Gluconeogenesis starts with the removal of amine group from the amino acid molecule, and this process is called as transamination or deamination. Pyruvate acetyl-CoA or intermediate of Krebs cycle may be produced after this process. Gluconeogenesis starts with pyruvate being converted to oxaloacetate by the enzyme pyruvate carboxylase. Oxaloacetate then will be further converted to phosphoenolpyruvate by PEP carboxykinase, and the following step is the reversal step of glycolysis until glucose 6-phosphate is produced. Glucose 6-phosphate will be converted to glucose by glucose 6-phosphatase. Glucose is now ready to fuel the brain and body during starvation.
Created using Powtoon.